Yeah, welcome everyone to our practical science, engineering, maths and technology page. Today we are going to be discussing physics. We have a physics question to answer. Here we go. A lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meters per second into a lead block of mass 0.95 kilogram. Given that the lead block can move freely, the final kinetic energy after impact is what? It's an obligate question. We have A, 50 joules, B, 100 joules, C, 150 joules, or D, 200 joules. Which is the answer? So we'll solve it. Solution. Now, for us to solve this question, let us replicate the scenario, the action. Now we have a bullet. Take this to be a bullet, and then that's the lead bullet. And then we have the lead block situated somewhere here. Okay, this block. Now the bullet is traveling at a speed of 200 meters per second. Okay, call this bullet M1. Let the mass be M1. The lead block is M2 and it's stationary. Okay, all right. So this bullet will hit this. So now we look at it in this way. With the first mass, we have M1 given to us as what? 0.05 kg. Okay, M2 is given to us as 0.95 kg, and the velocity of the bullet, let us call it V1 or V1, okay, and it is 200 meters per second. Okay, now these are the initial conditions. Now we know that the kinetic energy KE is given as half m bracket v square. This V is the final velocity after the bullet has hit the lead block. So we need to find out what is this final velocity. And now, if you look at this question, this is momentum that we're talking about here. That's the only way we can get the final velocity. Okay, so we have momentum says the sum total of the momentum, initial momentum, is equal to the sum total of momentum after impact. Okay, so we're going to find it. The sum total of momentum before the impact will be given by m1 times v1, the initial velocity, v1, okay, plus that of m2. Now we have m2 plus m2 times V2, which is not given, or is given, but we are going to explain it now. And that will be equal to the final velocity after the impact. We are going to take M1, let that final velocity be Vf, plus M2 times Vf. Because after the impact, both of them travel with the same velocity. Remember that M2 is free to move after the impact. Now, we'll substitute. M1 is 0.05 kilogram. So we have this 0.05 kg times, what is that velocity? 200 meters per second square. Per second, not square. Then plus M2 is 0.95 kilograms. So have this 0.95 kilogram, 0.95 times V2 is 0. The M2 was stationary in the initial condition before the impact. V2 is 0. So this is 0 here. And all this equation will be equal to M1 VF plus M2 VF. Now M1, it still remains 0.05, okay? So I have 0.05 times VF, then plus M2 VF, 0.95 times VF. Okay, so you can see that VF is common among them. So let's compute these guys. So this will give us 0.05 times 200 is 10. 0.05, right, times 200 is 10. Now 10 plus 0.95 times 0 is 0, okay? Plus 0. Is it equal to, bring out VF outside this bracket. So have VF bracket 0.05 plus 0.95, okay? Now, if you look at it, well, this 0.05 plus 0.95 is 1, okay? So this invariably gives us 1 times VF is VF. Therefore, VF is equal to 10, okay? Now, we formula for kinetic energy is given as half mv squared, okay? So we'll now get our KE, therefore is equal to half times the total mass. You can see that the total mass after the impact is the total mass. Now, after the impact, we have 0.05 plus 0.95, that's 1. So that's 1, then times VF, okay? VF, V final, all right?